quick examples. Here's an example of a reciprocal function, right? So we want to graph reciprocal functions. How do we do this? How do we graph a reciprocal function? Okay, right. So we're going to try to identify. We're going to start with a parent graph, which is there, right? That's our parent graph. So this is, we could call it P of x equals 1 over x, right? And that's the look of our parent graph. What are the values of a, h, and k? A is, no, 7, right? Good. It's 7. There's a. Oh, this thing isn't totally calibrated, is it? Let's see. There we go. No, it's good. It's good. So HK, what were the values of H and K? -2, -3. Good. Okay, so what's that telling me I'm going to do with my parent graph then? H and K tell me what? Okay. Left 2, I'm hearing. Down 3, so we go right to there. Perfect. Okay, that gets us to there. Now, what do we do once we're there? We said A was equal to 7, right? So what's that mean? I got to stretch it, don't I? So we're going to start, how do we stretch something like this? This is our anchor point, right? That's the reference point where the asymptotes cross. I'm stretching everything from there, okay? So then we're going to take this point here where we normally would go over 1 from the reference point and up 1, and we're going to go up how far? 7, exactly. So what's that look like? I'm pretty proud of this next little trick. This is a good one. Watch, wait for it. Ooh, how's that? Look at that, huh? So see that one gets stretched clear up to there. You like that? And then on the bottom side, that one gets stretched down by a factor of 7. Okay. So there's what we get. That's our, yeah. Here, I'll do it just like that so you can kind of see. For the notes, I'll leave it like that. Okay, give me 1 to 5. Does that all make sense? Okay, you always have the option too. I'll just point this out. You have the option if you want to. I don't think this is, I wouldn't do this, but you have the option of turning this into a rational function. We could write this as 7 over x plus 2 minus 3 over 1. And I could multiply the second fraction by x, the quantity x plus 2 divided by x plus 2. And then what's that give me? Well, I get a common denominator of x plus 2. And on the top, I'd get 7 minus that stuff, right? 7 minus 3 times the quantity x plus 2. And if I distribute the -3 and collect like terms, I just get -3x minus 6 plus 7 is plus 1 over x plus 2. So if you really want to, you could turn it into a rational function and then graph it using this techniques with a rational function. That's fine. I wouldn't do that. It seemed like it was easier the first way. Okay, so what about one like this that is a rational function? So they want us to find all asymptotes, x-intercepts, and y-intercepts for the graph of the rational function, and then sketch the graph of the function. So what is the, everybody just show me with your fingers, the horizontal asymptote is the equation y equals what? Okay, how come? What's the rule? Okay, good. Yeah, when we've got a rational function where the degrees of the numerator and denominator are equal, then the horizontal asymptote is given by the ratio of the leading coefficients. So the leading coefficients, I've got a 2 and a 1, right? So we get our horizontal asymptote is y equals 2. Okay, and I could take this guy down, slide him down, and there's my horizontal asymptote. Okay, what about my, does that seem really dark? Doesn't it seem a little? Well, I don't remember how to fix it, so I'm not going to deal with it now. Vertical asymptote. Do we have any? Show me with your fingers. X equals 1. Good. Good. And we know that because, oh man, this thing is really messing me up. X minus 1 equals 0 when x equals 1, but it's a unique 0 of the denominator. When I plug 1 into the top, in other words, if I did this, if I tried to evaluate this thing, if I plug in 1, I get 2 plus 3, I get 5 over 0, right? 1 is a 0 of the bottom, but not the top, which tells us vertical asymptote. Okay, so we can put a vertical asymptote at 1. Okay, how about x-intercepts? Where do x-intercepts occur? When it's, okay, when the function is 0, right? X-intercepts occur when y is 0. So the function equals 0 when the numerator or denominator is 0. When does a fraction equal 0? When the numerator is 0, right? If the denominator is 0, it's undefined. It equals 0 when the numerator is 0 and the denominator is not. So when does y equal 0? Well, that's going to be that part right there, isn't it? So we're going to get 2x plus 3 equals 0 when x equals what? Negative 3 halves? Okay, so we should get an x-intercept at negative 3 halves, which is negative 1.5. That's right there. How about a y-intercept? Where do y-intercepts occur? Yeah, okay, good. Y-intercepts occur when x is 0. So if I plug 0 in for x, that's just evaluating my function at 0. So if I plug 0 in, what do I get on top? 3. What do I get on bottom? So I get negative 3. So my y-intercept then should be at negative 3. And that tells me what's going on to the left of my vertical asymptote, doesn't it? I'm going to get this function. The graph should look like, well, not like that, like this, right? Correct? What about the other side? There's two possibilities. How would I know what's going on? Okay, there is some symmetry maybe, but how could I test? What could I do? Test point. Yeah, what would be a good x value to plug in? Well, I'm hearing lots of numbers. So x equals 0 is not going to help me for the right side. 2 would be a good one. Yeah, 2 is a good choice. Let's try that. So if we plug 2 into the function, what do I get on top? 7. What do I get on the bottom? 1. Okay, so f of 2 is 7 over 1, which is 7. So over 2 up 7. Well, that tells me what's going on then, doesn't it? It's got to be up there. It's got to be above the horizontal asymptote and to the right of the vertical asymptote. Okay, give me 1 to 5. Is that all making sense? Okay. Maybe we'll look at just one more today and we'll finish up one tomorrow. So how about this guy? Horizontal asymptote. Show me with your fingers. What's the y equals what? Okay, and the answer is what? 0. How come? What's the rule? Okay, good. If the denominator is a higher degree than the numerator, then we know that and why is this? Think about why this is. Horizontal asymptotes are what's occurring way out at the infinities, right? We're going to let x get really big in the positive or negative direction. As x approaches infinity, the bottom is approaching infinity infinitely faster than the top because it's an x squared on the bottom, right? Infinity squared is infinitely bigger than just infinity, okay? So we know that's our rule, right? Denominator's higher degree than numerator, then that's telling us that the horizontal asymptote is y equals 0. Okay, so we could, oops, I want to do that. So there's my horizontal asymptote on the x-axis. Okay, what about vertical asymptotes? What would I have to do to get vertical asymptotes? Factor, good, I got to factor the denominator. So if I do that, what does the bottom factor into? Okay. So what's that telling us about vertical asymptotes? Where would I get vertical asymptotes then? 5 and negative 5. Okay. Okay, so we could scoot those guys over. So there, I've got all my asymptotes. How about intercepts? Where's the x-intercept? X-intercept occurs when when y, which is the function, equals 0. For what x value does that function equal 0? 0, yeah, right? Because the numerator equals 0 when x is 0. Okay, so uh, so we get an x-intercept at 0, 0. What about, well, what's the y-intercept then? 0, isn't it? Yeah. Right, if I plug 0 in for x, I'm going to get 0 divided by negative 25. 0 divided by any non-zero number is 0. So that's both the x and the y-intercept. So now I got to get a graph out of this, though. What am I going to need to do to get a graph out of this? And there's a bunch of different possibilities that this thing could have. I got to know which one it is. The asymptotes help me a great deal, but I don't know if it's going to swoop down. Like if I'm looking at the middle piece, let's say, is it going to swoop down from above and then go down, keep going down on the right? Or is it going to do the opposite? Or is it going to swoop down and bounce back up, or start from negative infinity and bounce back down? How do I know? Test points, sure. Okay, so what would be good test points to choose? 3's fine. Yeah, we could try 3. So if I plug 3 into the function, let's see what happens. What's that give me? If I plug 3 in, what do I get on top? I get on the top again? 24. Okay. What do I get on the bottom? And I could just go there if I want to. Negative 16. So 24 divided by negative 16, isn't that equal to negative 1 point something, right? So what's that telling me? Okay, if I plug in 3, it's down here somewhere, right? It's pushing it down, so I know it's coming from down here, right? What's another test point I probably want to pick? How about negative 3? Okay, so if we try negative 3, what's that going to give me? What do I get on top if I plug negative 3 in? Negative 24. What do I get on the bottom? Same thing, right? Right? Because isn't negative 3 squared the same as 3 squared? Right? So I get, if I plug negative 3 in, I get negative 24 over negative 16. So that's positive 1 point something, right? So it goes back up, yeah. So it's doing that. So we know what the behavior is in the middle. Whoops, I missed the target there, didn't I? It's because this thing isn't calibrated. I'm blaming it on the calibration. You're not buying it? Okay, so that's not a very good looking graph. But anyway, there's the middle section, right? Okay, what's it doing to the left of the vertical asymptote at negative 5? How would I know? Check a test point. What would be a good value? Negative 8? Sure, negative 8. I like that. Let's try negative 8. So if we go f of negative 8, that's going to give me negative 64 on the top, right? And on the bottom, I'm going to get 64 minus 25. So 29, what is that? 64, 39? Okay, the important thing is positive or negative? Negative, yeah. Okay, so if I go out to negative 8, it was negative, which means it's coming down here. So what's that mean then? It's only one thing this thing could be doing. It never crosses the x-axis other than that one place. So doesn't it have to be doing that? Good, everybody agree? Okay, and then I would just have to check a point out to the right of the asymptote at x equals 5. We'd probably want to check, I'm guessing we'll just check 8, right? So if I plug 8 into this thing, I'm going to get positive 64 over positive 39, right? Positive over positive. So I'm getting a positive outcome at 8. So then we know it's doing this. And there's my final graph. Okay, we good with that? Okay, got one more sample problem tomorrow, one more example, and then you can have the rest of the period tomorrow to work on reviewing for the test. When's the test? Wednesday. There you go. Yes.